Okay, a clock consists of this physical pendulum which is composed of a length and a radius, and a kind of bar with a length L. The problem asks us to determine the rotational inertia which is going to be this. We're going to take is this. We need to take into account the parallel axis theorem, which tells us that the total inertia is going to be the inertia of the center of mass plus the mass times the diameter squared. So we have as data these two inertias of the rod here, of this thing, and of the sphere. So we're going to take the total inertia is going to be the sum of this plus the sphere contains this, and to take this into account also. So the sphere is 2.2/5 of the mass r squared, and this is going to be plus md is the length of this, so it's going to be ml squared. And after doing all the maths, we're going to determine that this in total inertia is going to be 43/30 ml squared, because it's asked us to determine the inertia in terms of m and l. So we have the first part of the problem. For the second part of the problem, they are asking us to tell the period during small oscillations. We have this formula that the period for a physical pendulum is given by this formula. The period is going to be 2 pi times the square root of the moment of inertia, which we just found, over the mass, the total mass times gravity times r. So the center of mass is at 3/4 of the pendulum, so we need to take that into account. We're going to substitute this into this formula. So the case B is going to be T equals 2 pi times the square root of the moment of inertia we just found, 30 ml squared, over mt, the total mass, which is 2m, times the gravity times the radius, which is the length at which the center of mass is located. So it's going to be 3/4 of L. After doing all the maths, we determined that the period is going to be 2 pi square root of 43/45 L over G. And that's going to be the second part of the problem. For the third part of the problem, they're asking us to determine for the period t, what should be equal to the length L. So we just found the formula that determines the period, which is 2 pi times the square root of 43/45 L over G. So that's asking us for t equals 2, what should be the value of L. So we need to equal this times to 2, which is 2 pi square root of 43/45 times L over G, which is 9.81. And we know that L is going to be equal to 1.04 meters. And that's the final result after isolating L.